Compounding is an amazing thing. Next time you're out with your friends, you can explain the marvels of compounding. As a matter of fact, a famous scientist once called compounding the most powerful force in the universe. That famous scientist was Albert Einstein. The same person who invented the atomic bomb, boom, said compounding is the most powerful force in the universe. Let's look at why this might be. We can start with, let's say, $10,000. We can start with $10,000 today at time zero, and we can look at what this $10,000 might look like as it grows at different interest rates. Let's say we went in 5-year increments so we can go a little further out in time. What I'm going to do here is grab the corner of the Excel sheet with this little crosshairs. It has recognized the pattern, and let's go out to say 100 years. We're going to use the same time value of money formulas that we've used before. Equals future value. We'll take our rate of 5%. We will fix the row of 3 with a dollar sign so that when we drag down in a moment, that doesn't move. The number of periods over here is 5 for this, and we will fix, in this case, with a dollar sign, the column so that when we drag it over to the side, the column doesn't move. Our payment is 0, and our present value is minus, always minus, this $10,000, and we will again fix the row so that as we drag down, the row doesn't move. So let's see first what we would have if we grew for 100 years, $10,000 at 5% a year. We would have $1.3 million in 100 years. That's pretty good. $1 million is nice to have. If we went to 10%, do we think that number will double or more than double? Let's take a look and find out. We drag this to the right, and then we can go ahead and drag it down. We will see that at 10%, we have $137 million. This starts to let you know the power of compounding. This is an exponential growth. Let's see what we'll get as we look at 15 and even 20%. We can drag these across and then down. We went from 137 million to $11 billion just by going from 10% to 15%. If we go from 15 up to 20%, we go from $11 billion to $828 billion, starting with just that same 10,000. Let's look at 25%. We'll drag and down and use the crosshairs to expand the cell, and we get, drum roll for the last one, $49 trillion. It's an astounding amount of money. Let's look at this visually so we can get another picture of how this growth occurs. We can look at maybe just the 10% growth. So we'll highlight those cells, go to Insert, Recommended Charts, and it chooses one typically that works, not always, but in this case, we have a great picture of what this looks like. So we can see that the growth starts out to look small, though if we were to zoom in, you would get this same basic exponential curve. We can see here out as time moves on, it starts to grow faster and faster. That's one of the really important takeaways from understanding compounding, is that the further out in time and the greater the rate, the more the growth is. If we were to go back and look at our numbers here, you can see, just comparing any row, that the further out in time and the greater the interest rate we use, the more the impact of compounding. So the old phrase, a penny saved is a penny earned, really starts to make more sense as we understand that when we save that money, we're not just saving that 1 penny or that $1 or that $100. We're saving all of the future compounded interest that money can create for us. Amazing stuff.